Hello, I am David W. Parker, and this is Programming Today I Learned. We're going to be starting this new series. It's called Algorithms. We'll be following CLRS, Introduction to Algorithms. It's been quite a few years since I was in grad school, and I've been looking at this book recently. And I said, might as well re-look and re-implement some of these things in JavaScript and just kind of remember all the things that I have long forgotten. So we'll just be going through the book beginning to end. Starting off, we're just going to look at Insertion Sort. This is in pages 18 through 28 of CLRS. And so we'll talk briefly about it. I'm not going to get too detailed into all the theoretical stuff, but we will look at big O notation and a little bit of that kind of stuff while we're looking at it. So Insertion Sort basically takes an array and it organizes that one piece at a time by forming a new sub-array of these sorted items in the index. So if we run this here, you can see I did it 3 different times. We'll look at the best case scenario is we're already sorted and it stays sorted throughout. Worst case scenario is when we're in the reverse order, and so it has to sort each of them one at a time going the reverse way. And then this is just a random case. This is the example given in the book, CLRS. It's kind of hard to visualize every single little thing that happens here. So I'm going to show you this really great resource. JasonPark.me has created this algo visualizer. And he's got a lot of different great algorithms on here that you should take a look at. We'll probably be going through a lot of them later. So he has his own implementation here, and so we could do is we can run that example, the exact same one that I had written out. And if you can see, here's the original thing. So we'll go ahead and run it. And you can see the way it sorts everything is it ends up copying over and then rerunning. Let me just explain on my code, it's a little easier. So basically we're going to take and go through every element in the array starting at the second position, because for all intents and purposes the first position is already sorted, will be the sorted part of the array. We'll grab the number from that piece in the array, and what we're going to do is for every item where the key is less than the subarray, then we'll go ahead and insert that into the proper position. So it slowly builds out a new subarray such that the subarray is sorted. That's a lot of arrays and subarrays. Honestly, what I would probably do is I would take something like this and I would pause it and I would look at each different thing that it's going through, and you could see what piece it's on, and you could see when it gets sorted and when it gets placed into the next position. That's honestly the easiest way to run through these kind of algorithms, I think, is visually. So you could see here we're starting with the second piece in the array, and it's going to copy the existing value over and then set the new one to be properly sorted. And then we'll go to the third one, and it'll go through each of these so long that that piece is smaller than. So the next one's already sorted, so it won't do anything. And this one is smaller than all of them, so it's going to go through the inner loop 4 times. And it'll set the current one and set that to the next one all the way down until it gets to the end. And then this one will go right to here. So it's a little confusing, a little bit, at first. Play with the algorithm visualizer that Jason Park has created. Step through back and forth so you can really see it. The best case scenario, as you could tell, 1, 2, 3, 4, 5, 6. Because everything is already sorted, this will never end up running because it never needs to. So we'll run through the array n-1 times, and we will never run through this. If we're running through the worst case scenario, though, every one of these is going to be smaller than all the previous ones. So we'll run through it n-1 times, another n times, So in terms of big O notation, the best case scenario is it's a linear function, so you'll have O of n. And the worst case scenario is it's a quadratic equation, so we'll have n squared. We generally care only about the worst case scenario, sometimes average, but generally the average is the worst case scenario. So for this particular example, we end up with a big O of n squared. So this is the first one we'll be going through. Hopefully I will get a little more clean in my descriptions of explaining these kind of things. But a few resources on here. Check it out on Wikipedia. I put the link to Jason Park's website on here, and then also the GitHub repository as normal. If you like what you've seen, thank you a lot. Subscribe. Talk to you later.